Hey guys, welcome back to yet another video on our channel Euclid Mathematics. So I'm back here with one of the excited news that we are going to start lecture series based on the M3 subject. Exactly, you heard right. We are going to start the lecture series based on Engineering Mathematics 3. Entire syllabus with entire previous year question paper, all important questions that I'm going to explain in our channel. From today onward, I'm going to upload similar videos in our channel. So stick to our channel, and in our today's video, I'm going to explain to you all, first of all, some of the basic concept, and at the end, we go for solving important questions. Okay, let's get dive into our today's lecture. Let's see what we have here. Okay, so here in our first chapter, as per the syllabus, we have linear differential equation with a constant coefficient. Linear differential equation with the constant coefficient. Now we can see here the meaning of linear differential equation. Okay, that means linear means the equation which has a power or which has a degree 1. Highest degree 1, that means it is a linear. Okay, so we are going to apply similar concept here in a differential equation with a constant coefficient, that means which has a constant coefficient with the differential equation. For example, let me write here one of the constant coefficient with a differential equation. As we can see here, a naught dy by dx. Now see that this one is a differential equation. Okay, first order first degree differential equation with a constant a naught. Okay, so that we can see here constant coefficient with a differential equation. Okay, yes. Now in our today's chapter, subsequently we are going to learn up to the nth order linear differential equation. Okay, nth order linear differential equation. Now what is meant by nth order linear differential equation? Now see that so if we have nth order linear differential equation means first order differential. First of all, learn first order differential equation. That means we take only first derivative of given function. So if you have function f of x, we take only the single derivative. So we consider this one is the first order differential equation. First order differential equation. If you again we are going to differentiate same function again, okay, then we write a second order differential equation. Okay, similarly we continue up to the nth order. That means we have to differentiate our function n times. Okay, like f to the power n of x, which is a nth order differential equation. Okay, which is a nth order differential equation. Now see that in your previous class or in your 12th standard, you all have learned how to find out the solution for first order first degree differential equation. Okay, in most of the case, whenever you have higher power, it is quite difficult to deal such examples. Okay, so here in my first part, I will explain to you all how can we solve first order first degree differential equation that you all already familiar with. Okay, so consider that if I consider here dy by dx plus py, which is equal to q. Okay, q is in the term of x. Okay, so if I have here first order first degree, first order first degree means, and order means number of times, how many times that function is differentiable. Okay, so that means it is the order of differential equation, and degree means highest differentiation to the power. Okay, so we consider it is the degree. So this one is the first order first degree differential equation. So we learn already how to solve first order first degree differential equation. Okay, I'm not going for entire process. I will explain to you all only the method that how can we find the solution using first order first degree differential equation. Then next we proceed here with the second order, third order and nth order. Okay, so it is quite easier for finding the solution for our first order first degree differential equation. Now see that we have first derivative here. That means only one times function it is differentiable given, and it's the highest power, it is also 1. That means first order first degree. So for finding the solution of this function, what we do, first of all we go for integrating factor. We used to find first of all integrating factor. And what is the integrating factor? Integrating factor is a e to the power integration of p of x dx. Okay, and that p which is coming from here, the coefficient of y. Okay, So this one is the integrating factor, and the solution for our differential equation we write y of x into integrating factor that we are getting from here, which is equal to integration of q of x. So where from that q of x coming, it is here we have right hand side, okay, that q of x coming here. So again into integrating factor dx plus c, okay. This one is the entire solution for first order first degree differential equation, okay. This one is the process that we are already familiar, but in our subsequent chapter or in our syllabus we are going to learn how to find the solution, for second order differential equation, third order differential equation, and so on, okay. So let me explain first of all you all how can we define nth order differential equation, okay. Nth order, that means it has n number of derivative which present in our equation, okay. And okay, so nth order differential equation with a constant coefficient. So we write a naught dx raised to n by d raised to n x by dx raised, sorry, we will take it in the form of y, okay. D raised to n of y by dx raised to n plus a1 d y raised to n minus 1 d n minus 1 by dx raised to n minus 1, okay. That means n minus 1 times its differentiation, okay, plus 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 plus, okay, plus plus we go for the last step, that one is the second last step we have here, a n minus 1 dy by dx, okay, plus a n which is equal to phi of x. We consider this one as the phi of x, okay. So this one is the nth order differential equation. So for solving the solution of nth order differentiable function using integrating factor or another method, it is not possible because we have present n number of differentiation. So it is not that easy to define our function here, okay. So in order to solve this such a differential equation, first of all we go for converting our nth order differential equation into the form of auxiliary equation, and once we get the solution of that auxiliary equation we proceed for the final solution, okay, using some of the standard form that we define the final solution for our nth order differential equation. Now see that how I'm going to transfer our nth order differential equation into the auxiliary equation, okay. Now see that as we have n number of derivative here, so we consider here d by dx as a capital D, okay, because now see that d raised to n by dx raised to n, it is not that easy to define. So convert that nth number of derivative into the some constant or some polynomial term in the form of polynomial terms, okay. Now see that, observe very carefully how I am going to define it here, okay. So a naught keep as it is constant, we are not going to change anything here in a naught, okay. I am keeping a naught as it is here. So d raised to n, okay, by dx raised to n, okay. So d by dx is a d, then d square by dx square, we write a d square, okay. That means take the square from both sides, that means double differentiation means d square, okay. So similarly we can define d raised to n by dx raised to n as d raised to n, okay. Yes, this is just a n number of power, we are considering it into the form of some polynomial, okay. So a naught keep as it is, d raised to n by dx raised to n, that means we write a d raised to n, okay. We are taking with this taking independent and dependent variable y and x, okay. So y take as it is here, okay, plus a1 d raised to n minus 1, okay. So we consider this one as d raised to n minus 1, okay, and into y plus 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 all the way up to an minus 1, okay. We can see here an minus 1 capital D y, d as a d by dx as a d, okay, y that variable I kept as it is here, plus an into y which is equal to phi of x, okay. This one is our given differential equation in the form of a polynomial, okay. And now see that we have y everywhere, it is remains same, take it outside from these all terms, so we get a naught d raised to n plus a1 d raised to n minus 1 plus an minus 1 d plus an, okay. And y outside here, I taken y out from here, which is equal to phi of x, okay. This one is our given phi of x. Okay, now see that we can observe here carefully a naught d raised to n, a1 d raised to n minus 1, n minus 1 d, and en. This is some sort of polynomial. Okay, so which type of polynomial you all have learned before? The polynomial of a degree n. So how you all have learned nth degree polynomial, like x raised to n, a naught x raised to n plus a1 x raised to n minus 1 plus a naught. This is the type of polynomial already you all have learned. Okay, so this is the polynomial that we got it here. Okay, and which is similar like this polynomial. So okay, so this is the polynomial in the form of x. This is the polynomial in the form of x, and this one is the polynomial in the form of a d. Okay, so we write this polynomial as f of d. Okay, this is the polynomial in the form of d. Okay, so this one is the polynomial in the form of f of x. Okay, as x variable is present, but in the form of this polynomial we have variable d which is present. Okay, so f of d into y which is equal to phi of x. Now see that f of d into y which is equal to phi of x, we have found it here. Okay, now we can observe here, so we converted nth order differential equation into the form of some sort of polynomial. Okay, we converted nth order differential equation in the form of polynomial. So how can we solve the polynomial? It is the next question to us here. Okay, because see that for finding the solution of polynomial there are several methods available. Okay, so if the polynomial is a linear, then you can easily solve the equation. Okay, linear means if we have polynomial, example, consider the example x plus 1 which is equal to 0. This is the linear polynomial, so we can write x which is equal to minus 1 as a directly solution. Okay, so similarly here we get the quadratic polynomial. So if you have quadratic polynomial, then you have to solve the solution. Okay, using if the simplest method, so many simplest methods are there you can apply. So if the roots are complex or quite complicated to find out, okay, for quadratic polynomial, so you have to use, okay, you have to use minus b plus minus square root of b square minus 4ac upon twice of a. Okay, so this one is the standard result that you can apply for finding the roots of our quadratic polynomial. Okay, so we'll get the differentiation in the form of f of d. Okay, so it is quite similar like the polynomial. So we are going to deal this one as we found the solution in our polynomial or solving of equations. Okay, so what happen if the equations are cubic? Okay, so if equations are cubic, okay, so this one is for the quadratic. Okay, this one is for quadratic. Okay, this one is for linear, this one is for linear. Okay, this one is for quadratic, for finding the roots. Okay, so we are working for finding the roots of polynomial. Okay, yes, after quadratic we are getting the roots in the form of cubic. Okay, okay, so if we have the root in the form of a cubic. Okay, so if simple results are applicable like a plus b cube, a minus b cube, a cube minus b cube, or a cube plus b cube, such results are applicable now, I will suggest you all guys directly apply these results. But what happen if the results not applicable there? Then we have one more standard method which is a synthetic division. Synthetic division for finding the roots of a cubic polynomial. Now see that this is not only applicable for the cubic. Okay, so you can apply it for the highest power. Okay, you can go for the highest power like a 4, 6, any highest power can be solved by synthetic division. Okay, so don't worry about it. Okay, don't get confused if I'm asking about synthetic division and these things. Okay, I'm going to explain each and everything here in my channel. Okay, this is all my responsibility. Okay, yes, let's go further. Okay, so we got the 3 types of the root here. Okay, what happen if the power which is 4th? Okay, so polynomial in the form of 4th power. Okay, so like a raised to 4 minus b raised to 4 in such a case. Okay, so how can we solve the polynomial? Okay, I'm explaining about the polynomial or equation. How can we find their solution? Okay, similarly applicable here for f of d. So a raised to 4 minus b raised to 4. So first of all we convert their 4th power into the square. Okay, so how can we convert? Now see that a square raised to square minus b square raised to square. So this one is the conversion of a 4th power into the 2nd power. Okay, and simple expansion, we know that a square minus b square as a minus b into a plus b. So this one is the simple expansion for finding the roots, okay, for finding the roots of our a square minus b square. So replace a square as a complete a, b square as a complete b, and replace the value here. You will get the factors for our solution. Okay, so this one is the for fourth power. So similarly, you can go for fifth power, sixth power, or n number of powers. Already I have explained similar method into my channel, so you can see that in my channel that how can we find the roots, okay, for our nth order polynomial or equations. Already uploaded into my channel. Okay, now let's move for the next part. After finding the roots, what we are going to do for finding the solution? So here we got the value, last term here, f of d into y, which is equal to phi of x. Okay, f of d into y, which is equal to phi of x. So if I consider phi of x as a 0, if I consider phi of x as a 0, then we get the polynomial f of d into y, which is equal to 0. Okay, if we get the polynomial f of d into y, which is equal to 0. We call this as associated differential equation. We call this one as associated differential equation. Associated differential or homogeneous differential equation, or homogeneous differential equation. We call this one as associated differential equation or homogeneous differential equation. And subsequently we go for finding the auxiliary equation. Okay, auxiliary equation. Auxiliary equation. Now most of you all are thinking what is meant by auxiliary equation. Auxiliary equation, it is the only that we are converting nth order differential equation into the sort of polynomial, so it is easier for finding their solution. Okay, so this one is the auxiliary equation. Okay, so once we get the auxiliary equation, we will get like for example, we get that auxiliary equation in the form of a square, cube, or nth power. Okay, so this one is the auxiliary equation. So we are going to find the, subsequently we are going to find out the roots or solution for our auxiliary equation. And once we get the solution, we go for at the end for finding the solution for differential equation. Solution for given nth order differential equation. Now see that we have two types of the solution here. After auxiliary equation, we are getting solutions or oblique roots of differential equation. Solution or roots of differential equation. Okay, so once we got that solution, okay, once we got that solution, we write into the two form, which is one is the CF, which is a complementary function. We write a complementary function. We write this one as a complementary function, and pi, which is a particular integral. Which is a particular integral. Okay, which is a complementary function and particular integral. These two type of the solution, we are getting it from our roots. Okay, so once we got this solution, we write a complete solution or general solution. We write complete solution oblique general solution as complementary function plus particular integral. Okay, we write this complete solution or general solution as complementary function plus particular integral. Okay, this one is our required solution for nth order differential equation. Now see that guys, how easy the solution it is. Okay, so it's nothing difficult. We just have to solve here quadratic equation, cubic equation, and nth power equations. Okay, that is only the differential, that is only the nth order solution for nth order differential equation. Now see that which is a very much important topic, always asked in a university question papers. Okay, this one is a complete solution for and general solution. So that is for my today's lecture. In my tomorrow's lecture, I will explain to you all, or in my next lecture, I will explain to you all how can we write the solution. How can we write the solution using the roots of our given auxiliary equation. Okay, so that is for my today's lecture. So if you want to see the notes, you can refer here in my notebook. I'm showing you all the notes for my today's lecture. So nth order linear differential equation and its solution. Okay, you can see the notes here. Observe it how I have done it here. Till y of x is equal to complementary function plus particular integral. Okay, that is here for our today's lecture. I hope you all have understood. Even after, if you have anything doubt difficult, let me know in my comment section. I will come up with a similar videos. So thank you everyone. Thank you for our today's lecture. We'll stop it here. So thank you everyone.